Hello everyone. I hope you are enjoying sessions this morning. I am Dipali Kushrest. I have got more than 16 years of versatile experience in designing, developing and implementing the software applications and microservices. Presently, I'm working with Royal Bank of Scotland, which is also known as NetWest. Microservices and containers. These are the buzzwords in IT industry and are an increasingly important way for developers to package and deploy their applications. So, in next 40 minutes, we will understand the key concepts to use containers as fundamental unit of compute and to deploy any workloads in AWS. Ready for it? And we plan to cover containers overview, Docker concepts, Amazon ECS and ECR, which are especially the containers orchestration services in AWS, and then finally a demo to containerize microservices. But it worked on my machine. This is one of the big problems in a software developer's life, and I'm sure you must have encountered it in some shape or form. So why it happens that a particular change works on developer's machine, but it fails on other machine or onto the different environments? There can be different reasons for that, but some common reasons are that there can be different setup on different machines. There can be different versions of software installed on different environment. There can be missing configurations. Or it might also happen that you might have hard coded your directory path in the code itself. So, to address these problems, a company named Docker came up with an idea to package all these things together and put it into a box, which is known as container. So you can ship your application code along with its dependencies, runtime, configurations together as a single unit on any environment and can run it on any operating system, either on-prem or on cloud. And due to this offering, Docker became the world's leading software container platform. It actually automates the repetitive task of setting up and configuring development environments so developers can focus on what really matters to them, that is building great softwares. Now let's understand how Docker works. Now since Docker provides a standard way to run your code, Docker is actually an operating system for your containers. So now an obvious question comes that how it is different from virtual machines then? So in virtual machine, the concept is to virtualize the server hardware. So you can install multiple operating systems onto a single hardware. However, in case of containers, operating system itself is virtualized. And then Docker engine is installed on each server, which lets you create and run multiple containers on single operating system. Understood? So in virtual machine, we virtualize the server hardware, while in case of containers, we virtualize the operating system. So this is the key difference between these two. Now let's talk about some of the benefits of containerization. Now, since container provide the process isolation, so it made it feasible to break huge monolith applications into small independent components and run them as microservices. And containers also standardize the code deployment. So you can easily communicate between, you can easily communicate and create workflows on for your hybrid applications. And it definitely made it very simple to migrate applications from on-premise applications to cloud without any code changes. And you can also package your ETL jobs into the containers and can start and scale them whenever needed. And it comes in very handy to scale containers while training the machine learning models and run them on any environment. You can also use containers to build platform for developers without needing to manage the underlying infrastructure. Now, $1 million question is that why containerization on AWS? Simply because AWS is the number one place to run containers, and 80% containers on the cloud runs on AWS. Some of the renowned customers like Samsung, Expedia, KPMG, GoDaddy, they have chosen AWS as their container orchestration platform due to its security, reliability, and scalability. AWS offers around 210 security and compliance offerings, which is significantly more than any other competitor as on date. And since AWS has its infrastructure presence worldwide, so you can actually scale up, you can actually create and scale your containers anywhere in the world, which covers 22 regions and 69 availability zones. And this presence is more than double from any competitor. And this AWS Container Services, this is actually deeply integrated with other AWS services. So you can actually leverage the agility of containers with the security and elasticity of the cloud and can leverage other storage and monitoring services. So this is how AWS is so popular for container orchestration. Now let's talk about Amazon ECS, Elastic Container Service. So ECS is the service in AWS that handles the orchestration and provisioning of Docker containers in AWS. And some key benefit of using AWS ECS are that ECS offers serverless computing. So now you have a choice here in AWS that either you can create your containers on traditional EC2 instances and can choose to manage yourself, or if you want to get rid of that infrastructure overheads, then you can choose to go serverless via Fargate. So Fargate is the way which lets us enable to go serverless. And since ECS is fully managed service, hence it is highly scalable. And it is very secure to launch your containers into ECS because it allows you to launch container into your own VPC. So you can create your own security groups and network access control list. And on top of that, ECS is very much optimized for cost. With you know, you can leverage, you can reduce cost of your containers further by 90% by choosing the spot instances instead of on-demand instances. And this option is available with both EC2 instances as well as Fargate tasks. Now, this is a simple workflow for any ECS application on AWS. So what you need to do first of all, that you need to upload your container image into a repository. So here the service name is Elastic Container Registry, ECR. It is simply a repository to store container images. All right. And it is similar to like other container registries like Docker Hub. But the key difference is that Docker Hub, by default, it is a public repository, while ECR is a private repository for your account, hence more secure. So now ECS use this image to build your application into the ECS, and then you can choose to run your application via EC2 or via Fargate and can run and monitor your application. Now, there are few key terms which we should understand before we actually proceed on AWS on ECS. So, very first thing when we start on ECS comes ECS cluster. So ECS cluster is nothing but it is a group of EC2 instances which has ECS agent installed on it. All right. So once we have cluster ready, then next step is to define the application, which is known as task definition here. So task definition is nothing but a blueprint of your application which actually tells that how a Docker container should launch. Okay. So once you have your cluster ready, that is the infrastructure machine ready where you want to run your containers, then exactly what you want to run there, you need to define a blueprint of your application. Then now you need to really create a task to run that application. So task is actually the lowest deployable unit in ECS, and one container can have multiple tasks. Okay. Then the next step is to define a service there. So service is nothing but a grouping of tasks. So you can have multiple tasks to run your application. And service is nothing. It's just a like contract where you describe that how many tasks you want to run for this particular application at any given point in time. And service is something which has some endpoint associated with it. And so you can expose this endpoint to your API gateway or to the outside world. So this is how a traditionally, which is the traditional architecture of running, creating and running containers onto the ECS. So what all we did so far is, first of all, what we need a image, container image, which we need to put into the ECR, that is Elastic Container Repository. So once we have that repository image, then next step is to move on to the ECS. So in ECS, first of all, you need to create ECS cluster, where you will define that you want to create your cluster on EC2 or onto the Fargate. So once you have your infra, basic infra ready, Then you need to define your application blueprint, which is known as task definition. Okay, and once you have your task definition ready, then you need to create tasks and services so you can actually run your application. All right. So these are just the concepts. Now, what all things we need to do when we really need to get in action? So as we just discussed, that first of all, we need to create a microservice. To create a microservice, bare minimum things we need, that we need a Docker file, and we need to create image from that Docker file. So let me just show you. I have created. So I'll just demo this to you as well. So this is my EC2 instance where I have created this Docker file. So if you see, so this is the Docker file. Let me just quickly create a new session so you can clearly see these things. So here I have just these two files, Docker file and there is some jar file. Okay. So if I check this, the content of my Docker file, so in this Docker file, I have taken some base image, some JDK base image, and then I'm exposing port 8080 for this application. This is the name of my jar file, which is the actually application file. Okay. So these are the key things here. What this jar file has a very simple hello world. So this is an application which is simply printing hello world. All right. So now let's go back onto the slide. So first of all, we have created this Docker file, and then we need to create image from this Docker file. That I will show you in a moment. Post that, once we have image created, we need to really push that image onto the ECR repository. Let me show this to you. Now, if I go to my AWS account, so here I am on to my AWS account. Here I am on to the Elastic. So this is the AWS dashboard. So I have opened ECR Elastic Container Registry. So in this registry, as of now, I have these two repositories, Hello Repo and some microservices repo. Okay. So how you can create a new repository? You simply need to hit this create repository and provide some repository name here, and it will create a blank repository for you. Similar way, I have created this hello repo. So in this hello repo, I have this one image, and this is the image for my hello world service. Okay, and how we can push image to this repository? So you need, once you are into this folder, you need to click on this view push commands. So since I'm using, okay, so these are the commands that this is how you really, using the AWS CLI on your EC2 instance, you can push this image into the, so here you have created this Docker image, Docker build -t hello repo, and once you have built your image, then you need to create a tag for your image, and finally you need to push this image. This is the push command. So you simply need to really copy, paste and execute these commands onto your EC2 instance, which will push this image from your EC2 instance to an ECR repository. Okay. Now let's go back to the slide and see what is the next step here. We covered this, we covered this. So once we have created ECR, now next step for us is to create ECS cluster. For that, we need to go on to the ECS. So let me open ECS from here. So here we are onto the cluster, and then we need to create a cluster. So I am using this EC2 Linux instance. So let's choose that and hit on next tab. Provide some cluster name. I'm just doing hello cluster. I'm choosing on-demand instances as of now. Since it is simple Hello World application, we can choose some small instance. So let's choose it from some T2 family. So I'm choosing T2 small instance here. I'm just creating one instance for this demo. And here we need to choose the key pair for my instance, so I can actually SSH onto this. So since I am into the Virginia region, I have this key pair, Virginia key pair. And here I can choose my VPC, that in which VPC I want to really create this cluster. So this is the additional security which you can put onto your cluster, on your container. So I'm choosing this cluster, and for simplicity, I'm choosing it like subnet A and B. Then we need to choose security group as well. So I'm choosing this launch wizard one. I will tell you the reason in a while. Okay, so that is it. Rest we can take the default option. So here if you see the security group, this is the security group which we have chosen. So why I have picked this particular security group? Because since my application is running in my image, my application is running on which port? 8080. So I have opened this port 8080 into this particular security group. So this is the region. This is the reason I have picked this particular security group. All right. So now we have created ECS cluster. So now we have our infra ready, that where actually I want to launch my containers. So I have created that I would like to launch my container on EC2 instances. Okay. Now next step is to create the task definition. And what, as we discussed, task definition is nothing. It is just a blueprint of your application. So how to create task definition here? So let's go back to the ECS console. Okay. Here I am into the task definition, and I can create a new task definition here. So I'm using the EC2. I need to provide some name to my task definition. So simply I'm saying hello PD, hello PD. And then I will not provide any, I will go with the default role. And the key thing here, that you need to provide, you need to add your container image. So when we were onto the ECR, here we are. We need to take this image identifier of our ECR image and put it into the task definition, and need to give some name to this container. So this is hello container, which need to really refer to this particular image. Okay. And here we need to define some memory limit as well. So let's go with 512 MIB. And this is the important thing, that here you need to define the port mappings, that which is the host port of this particular application, and what is the container port. So what is the mapping? So we know that in container we have this port is 8080, let's, for the simplicity, let's keep it 8080 at the host as well. All right. So here we have defined the host port mapping. Rest everything, I believe we can keep default. Simply add this container information and then create your task definition. So now it says that we have created task definition successfully. Once we have the task definition ready, what is the next step for us? That we need to create service. And what was the service? Service is just like one or multiple tasks to run your application, which is defined here in task definition. So how to create service here? Go back to your cluster, open your cluster, hello cluster. There you will see this tab service. Then here you need to create service. What is the launch type for my service? It is EC2, which is the task definition we created. We created hello TD and we have just one revision out of it. Cluster is hello cluster. Yeah. And we need to provide some service name, hello service. How many tasks we want to run? For this demo, let's keep one, but yeah, ideally we run, like, in order to have the high availability, we generally run at least 2 or 3 tasks here. Okay. And here you can also define the deployment type for your task. As of now, I'm going with this default rolling updates. You can also, as we discussed, that service provides some endpoint to your application. So you can choose some load balancer to be your application. So this is a traditional practice we follow. This is the normal architecture cluster used to have. That first of all, you have some application defined, you run multiple instances of that application behind load balancer, and then you expose this load balancer DNS to your API gateway. So this is the place where you can link it with your load balancer. Then you can also set up scaling policies here, that on what are the conditions when you will really like to scale up or scale down your application. And then you can simply hit create service. So now it says service created. Let's check the service. So here it says desired status is running, but it is still pending. It will give a while. Yeah, it will take a while. So now it is in running state. So now let's check the detail. So this is the hello container task. What are the details? That these are the mappings, and this is the external links. So this is the IP address of our application where it is running, and this is the port where it is running. So let's check whether it is accessible. Yeah. So this is the simple hello world which we created in our application. So our container is up and running. Got it? So what all the steps we did so far? Very first thing we did, that we created our application. It can be anything. It means in this demo, I have taken this some Java application, which is simply displaying a hello world. Instead of Java, you can create your application anything like Python or any other language you are comfortable with. So once you have your application or microservice ready, you need to create Docker file for that. And once you have Docker file, you need to create image. Once you have the image ready, you need to create a repository using ECR. And why ECR? Because this is private, but AWS does not restrict you to use only ECR. You can also provide like your repository link from your Docker Hub. Okay, so you need to push this image into the ECR, and then you need to create a cluster into ECS where you need to decide that you want to run it on EC2 or you want to go serverless via Fargate. Once you have that basic infra ready, then you need to create your application. Then you need to define your application via task definition, and then you need to create a service. So in this application, basically you will define this container information. So this is how this linking happens, and then you need to create service to actually run this application. Okay, and if you go back to your EC2 console, you will see that, because we have created like we have given key pair name because we wanted to see the instance. So, this container, if you see your EC2 dashboard here at this stage, so your ECS cluster has actually created this ECS instance. So you see the tag here. So this is something which we have not created. It is actually created via your container ECS application Hello Cluster. So it has actually created this particular EC2 instance, which you can monitor and maintain. You can actually log into this SSH to this particular instance because we have the key pair through which we actually created this container. So I think, yeah, that is really it I had to demo for today's session. I know, like, it looks simple when you are comfortable with it, but you might struggle when you try to do it for the first time. So I have listed down the detailed steps, this detailed tutorial onto this Medium blog. So you can go back and practice. You can follow this tutorial. So here it is. Like, if on Medium you see this tag learning.dipali, then you will find that there is a tutorial published on containerize microservices with Amazon ECS. This has like step-by-step process for you to follow. So you can definitely practice and can create your workloads on EC2. Happy learning, guys. Thank you.